Good morning. Today we're going to continue solving our trig equations. To be able to start with this first one, notice that it is actually a quadratic trig equation. We have a squared term, a linear term, and then a constant. So whenever you have three terms, try to factor this. So we're going to just begin factoring. Let's put down two sets of parentheses. Our variable, instead of just being x squared, is going to be the trig word. So we're going to have our sine theta, and since there's a leading coefficient, we'll have 2 sine theta. If you multiply those together, that would give us 2 sine squared. Our last sign is negative, so we know we're going to have a plus and a minus sign. So we can put our plus and minus signs in. The last term is 1, so we have to multiply to equal 1. Only combination. Check your outside and inside terms from FOILing. Outside is sine theta, inside is negative 2 sine theta. That gives us a middle term of negative sine theta. So it does check out. Once you have it factored, what we want to do is find our answers. Set each parenthesis equal to 0. So we set the first one equal to 0. We set the second one equal to 0. Solving this first one, this minus sign that's here, we have to add over, so that gives us sine theta equals 1. Grab your unit circle. Where does that happen? Where is sine theta equal to 1? Only happens one place, and that happens at pi over 2. So that would be the answer for that factor. Let's solve the other one. We need to move our plus 1 to the right side, so 2 sine theta equals negative 1. Let's divide by 2. Sine theta equals negative 1/2. On the unit circle, where does this happen? Where is sine negative 1/2? It happens 2 places. It'll happen at 7 pi over 6 and 11 pi over 6. Those would be the 2 answers for that. So this particular problem actually ends up with 3 answers in one revolution around the circle. Okay, let's try another problem. Now, as you can see in this second equation, we have both sine squareds and cosine squareds. So this is where the work that we did last week, verifying identities and using our formula page, going to come back into play now. So what we're going to have to do is we have to get both the trig words to be the same word. Let's try to break both of these down into signs. So what we'll do is we'll continue. We've got sine squared. 4 minus 2. From your formula page, find a Pythagorean identity. What can we change this? This is 1 minus sine squared. So we're trying to get both the trig words to be the same word. You could have changed them both into cosines, but I decided to change them into sines. So now let's simplify a little bit. We have sine squared equals 4. Let's distribute 2. Negative 2 times that will give us positive 2 sine squared. Next, what we want to do is let's get everything on the one side of the equal sign. So I'm going to move everything to the right side. That is going to give us sine squared theta. 4 minus 2 is plus 2 equals 0. Now, I don't have a linear, just a sine term. I've got sine squared. So let's solve this by square roots method. So I'm going to subtract my 2. I have sine squared equals negative 2. What happens when we take the square root of a negative number? Yeah, it's imaginary, right? So that tells us we have no solution. So there's no solution for this problem. Okay, let's try one more example. In this final example, again, we have sine and cosine squared. Our formula page has things that we can switch back and forth with our squared terms. So this one, we would need to change the cosine squared into sines. So let's do that. We have 1 plus sine theta equals 2. We can change cosine squared again into 1 minus sine squared. Let's distribute this. 1 plus sine theta equals 2. 2 times this would be minus 2 sine squared theta. Now let's move everything over to the left side. If we do that, we will have 2 sine squared theta. We will have plus sine theta. And we'll have minus 1 equal 0. Okay, now again, this is very similar to the first example. We have 3 terms. What we want to be able to do, since it's quadratic, let's factor this. So we put down our 2 sets of parentheses. Again, we'll have sine as our variable, and this one will be 2 sine. Our signs in the plus or minus signs will have to be opposite, so we're going to have a plus here and a minus here. 1 is our last, so we can factor this. Once we have this factored, set each one equal to 0. Sine theta plus 1 equals 0. 2 sine theta minus 1 equals 0. Subtract our 1 gives us sine theta equals negative 1. On your unit circle, where does that happen? That happens at 3 pi over 2. This one, let's add 1, divide by 2. So where is sine equal to 1/2? This time it happens at pi over 6 and 5 pi over 6. So again, we ended up with 3 answers to this. Okay, let me know if you have problems today.